హాయ్ స్టూడెంట్స్, వెల్కమ్ టు గోవిద్య. ఈరోజు మనం ALP CBT-02 సంబంధించి ఎలక్ట్రీషియన్ ట్రేడ్ మాక్ టెస్ట్ 5 సొల్యూషన్ డిస్కస్ చేద్దాం. ఓకే, ఫస్ట్ క్వశ్చన్, 1 volt is same as, okay, 1 volt is same as 1 joule, 1 coulomb, 1 joule per coulomb or 1 coulomb per joule. Okay, voltage is equal to, okay, work by charge, okay, the unit of voltage is volt is equal to work, the unit of work is joule, okay, the unit of charge is coulomb, okay, 1 volt is equal to joule per coulomb, okay, option C is the correct answer. Okay, next question, the potential at point is 20 volts, what will be the work done to bring a charge 0.5 coulombs from infinity to that point? Okay, voltage is given and charge is given, we have to find work done. Okay, we have one formula, voltage is equal to work by charge, okay, voltage, the voltage is 20 volts, okay, work we have to find work, charge is 0.5 coulomb, substitute here, 20 volts is equal to work by charge 0.5, okay, work is equal to 20 into 0.5 is equal to 10 joules, okay, work is 10 joules. Okay, from the options, option B is the correct answer. Okay, next question, a 10 ampere source is connected across parallel resistors of 3 ohm and 2 ohm. Okay, 10 ampere current source is connected across the resistors, parallel resistors of 3 ohm and 2 ohm. Okay, current through 2 ohm resistor is, okay, current source 10 ampere current source is connected, this is 10 ampere current source is connected across 3 ohms and 2 ohms, okay, we have to find current flow through the 2 ohm resistor. Okay, this is current flowing through 2 ohm resistors. Okay, we have to apply current division rule. Okay, we have to apply current division rule. Okay, okay, current through 2 ohm resistor is equal to total current into 3 by 2 plus 3 is opposite resistance by total resistance. Okay, total current I is equal to 10 by 3 by 2 plus 3 is equal to 5 1 ja 5 2 ja 2 into 3 is equal to 6 amperes. Okay, current through 2 ohms resistor is 6 amperes. Okay, from the options, option A is the correct answer. Okay, next question, capacitance is the ratio of, okay, capacitance is the ratio of voltage to voltage or voltage to charge to voltage or charge to charge. Okay, we have relationship between capacitance, charge and voltage, that is Q, charge is equal to capacitance into voltage. Okay, capacitance is the ratio of C is equal to Q by V. Okay, Q is charge by voltage, capacitance is the ratio of charge to the voltage. Okay, from the options, option C is the correct answer. Okay, next question, the conductance of a conductor are having resistance of 100 milliohms. Okay, we have to find conductance. Okay, resistance value is given. Okay, resistance R is equal to 100 milliohm. Okay, we have to find conductance G is equal to 1 by R, reciprocal of resistance is called conductance. Okay, substitute here 100 milliohms means 1 by 100 into 10 power minus 3 ohms. Okay, 1 by ohms. Okay, we can also write 1000 by 100. Okay, 0 will cancel, 1 by ohms. Okay, 1 by ohm means Siemens, 1 by ohm is also called Siemens or mho. Okay, or mho. Okay, now we will get 10 Siemens or 10 mho. Okay, from the options, option B is the correct answer. Okay, next question, the energy stored in capacitor, okay, W is equal to 1 by 2 CV square joule, or W is equal to 1 by 2 Q into V, or W is equal to Q square by 2C joules, okay, and all of the above, okay. Energy stored in capacitor, okay, energy stored in capacitor. This is capacitor, okay. Current through capacitor is I, okay. Voltage across capacitor is V, okay. We have one formula for energy, E or W, okay. Energy stored, W is equal to 1 by 2 CV square, okay. 1 by 2 CV square. Option A is right, okay. Next we have to verify option B, okay. We know formula Q is equal to CV, okay. Q is equal to CV. Substitute here CV. We can also write 1 by 2 CV into V, okay. V square, V into V, okay. 1 by 2 CV. CV is equal to Q, okay. CV is equal to Q. We can also write 1 by 2 QV, okay. Work is equal to 1 by 2 QV, okay. 1 by 2 Q into V. Option B also right, okay. We have to verify option C, okay. Option C, okay. Work or energy is equal to 1 by 2 CV square, okay. Multiply C by C, okay. We can also write 1 by 2 CV whole square by C, okay. Now we have to write Q is equal to CV, okay. CV is equal to Q. We can also write 1 by 2 Q square by C, okay. Energy stored is equal to 1 by 2 Q square by C, okay. Option C is also right, okay. Now so answer is all of the above. Option D is the correct answer, okay. Energy stored in capacitor is 1 by 2 CV square and also 1 by 2 QV and also Q square by 2C, okay. All of the above, okay. Next question. A copper wire having resistance R, okay, stretched to twice of its length. If the value remains unchanged, then its new resistance will be, okay. Manaki oka wire, copper wire ni we have to stretch, okay, double twice of its length. Chesinappudu manaki new resistance enta, okay. This is initial conductor having length of L, okay, length is L, okay. Now the resistance is R, let us say R, okay. Now the conductor is stretched, okay, stretched to the twice of its length, okay, twice of its length. Length is 2L, okay. Now R new will be R new. What is R new? Okay, we have to find, okay. Now I will give one formula. R new is equal to N square into R old, okay, N square into R old. N is the stretching, how much length we have to stretch it, okay. Double of its length. N is 2, twice of its length. Here N is 2, substitute here. R new is equal to N square means twice the length, okay. N is 2 square into R old is R, okay. 2 square means 4R. R new is 4R. Option C is the correct answer, okay. మనం వైర్ ని స్ట్రెచ్ డబుల్ ద its length స్ట్రెచ్ చేసినప్పుడు రెసిస్టెన్స్ అనేది 4 times ఇంక్రీజ్ అవుతుంది, ఓకే. నెక్స్ట్ క్వశ్చన్. The total resistance in the circuit, okay. Here 8 ohm and 8 ohm are connected in parallel and the combination is connected in series with 21 ohm, okay. Here 8 ohm and 8 ohm are connected in series and the combination is connected in 8 ohm and 8 ohm are connected in parallel and the combination is connected in series with 21 ohms, okay. Now we have to find R effective, okay. R effective, okay. Now here 8 ohms and 8 ohms are connected in series, okay. The combination is 4 ohms, okay. Now 4 ohms and 20 ohms are connected in series, okay. R effective is equal to 4 plus 21 is equal to 25 ohms, okay. From the options, option A is the correct answer, okay. Next question. A battery is connected across a resistance of 20 ohms and what should be the electromotive force? We have to find electromotive force, okay, of the battery if the current flowing through is 0.75 amperes, okay. We have to find EMF, okay. EMF is equal to current into resistance, okay. What is current? Current is 0.75 amperes and resistance is 20 ohms. 0.75 into 20 ohms, okay. We will get Okay, 0.75 into 20, 0.75 into 20, we will get 15 amperes. Okay, 15 amperes is the correct answer. Option D is the correct answer. Okay, next question. A 10 ohm resistor is connected across 100 volt DC source. Okay, 10 ohm resistor is connected across 100 volt DC source. What will be the value of current flowing through the circuit? Okay, resistance value is given and voltage is given. We have to find current. Okay, apply Ohm's law. V is equal to IR. Okay, V is equal to IR. V, what is the value of V? 100. Okay, I, we have to find current. What is the value of resistance? Resistance is 10. Okay, 10 1 ja, 10 10 ja. Okay, I is equal to 10 amperes. Okay, 10 amperes. From the options, option C is the correct answer. Okay, next question. The reason for using high voltage transmission in electric power is, okay, of electric power. Okay, high voltage, man transmission line la high voltage use cheyanika reason enti? Okay, we know the formula. P is equal to VI cos pi. Okay, VI cos pi. Okay, V is equal to 1 by P by I cos pi. Okay, here we can also write V is inversely proportional to I. Okay, V is inversely proportional to I. Okay, if we increase voltage, okay, if we increase voltage in transmission line, the current will be decreased. Okay, if current decreases means copper losses is equal to I square R. Okay, if current decreases, I square R will decreases, copper loss will decrease, and also voltage drop is equal to IR. Okay, if current decreases, voltage drop is also decreases. These two are advantages. Okay, okay, from the options, increase the system stability? No. Okay, power factor is increased? No. Reduction in transmission losses? Option C is the correct answer. Okay, next question. The percentage of regulation in transmission line. Okay, regulation is equal to, percentage regulation is equal to, okay, sending end voltage Vs minus receiving end voltage Vr by receiving voltage Vr into 100%. Okay, this is voltage regulation in transmission line. Okay, from the options, option B is the correct answer. Vs minus Vr by Vr into 100. Okay, next question. Ferranti effect applicable for, okay, Ferranti effect applicable for light load lines or no load lines or both A and B, neither A and B. Okay, what is Ferranti effect? Ferranti effect ante receiving end voltage is greater than sending end voltage under no load condition and light load condition. Okay, Ferranti effect. Okay, this is transmission line. Okay, this is sending end voltage Vs. Okay, this is receiving end voltage Vr. Okay, Vr receiving end voltage is greater than sending end voltage under no load and light load condition. Okay, this is due to charging current. This is due to charging current. Okay, Ferranti effect is due to light load lines and no load lines. Okay, both A and B. Option C is the correct answer. Okay, next question. A battery of capacity 100 ampere hour draws a current of 8 amperes. Okay, battery capacity is given and current is given. We have to find time. Okay, discharge time. Okay, we have one formula for battery capacity. Battery capacity is equal to current into discharge time. Okay, battery capacity is given. Battery capacity is 100 ampere hour. 100 is equal to current rating is 8 amperes is into discharge time T. Okay, T is equal to 100 by 8. Okay, 8 1 ja 8. Okay, 20 remains. 8 2 ja 16. Okay, 44 remains 0.5. Okay, 8 5 ja 40. T is equal to 12.5 hours. Okay, from the option B is the nearer value for 12.5. Okay, option B is the correct answer. Okay, next question. If a 100 ampere hour battery is used for 5 hours continuously, okay, the current supplied by the same is, okay, here battery capacity is given and time is given. We have to find current. Okay, battery capacity is equal to current into discharge time. Okay, battery capacity is 100 ampere hour. Current we have to find. Okay, discharge time is 5 hours. 5 1 ja 5 20 ja. Okay, I is equal to 20 amperes. Okay, 20 amperes. From the option B is the correct answer. Okay, next question. How much is the output voltage if 5 carbon zinc cells are connected in series? Okay, if 5 carbon zinc cells are connected in series, what is the terminal voltage? Okay, this is one cell like this. This is one cell like this. 5 cells are connected in series. Okay, each is having value of E. Okay, now we have to find terminal voltage Vt. Okay, Vt is equal to number of cells N into each cell EMF E. Okay, terminal voltage is N into E. Okay, here carbon zinc cell. Okay, carbon zinc cell EMF వచ్చేసి average EMF వచ్చేసి 1.5 volts. Okay, 1.5 volts. Okay, now number is equal to 5 cells. 5 N is equal to 5. Vt is equal to 5 into 1.5 is equal to 7.5 volts. Okay, terminal voltage is 7.5 volts. Okay, option B is the correct answer. Okay, next question. The cells are connected in series. Okay, cells ni series connect చేయడం వల్ల మనకి ఏం జరుగుతుంది? Okay, decrease the internal resistance or decrease the output voltage or increase the output voltage or increase the current capacity. Okay, cells are connected in series. Cells, okay, connected in series. సిరీస్లో కనెక్ట్ చేయడం వల్ల మనకి వోల్టేజెస్ అనేవి యాడ్ అవుతాయి. ఓకే, ఒక సెల్ ఈఎంఎఫ్ అనే యాడ్ అవుతాయి. ఓకే, టు ఇంక్రీజ్ ద వోల్టేజ్ ఓకే, అలాగే ప్యారలల్ కనెక్ట్ చేయడం వల్ల ఓకే, సెల్స్ ఆర్ కనెక్టెడ్ ఇన్ ప్యారలల్ టు ఇంక్రీజ్ ద కరెంట్. ఓకే, హియర్ సెల్స్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్. ఓకే, సిరీస్లో కనెక్ట్ చేయడం వల్ల మనకి వోల్టేజ్ అనేది ఇంక్రీజ్ అవుతుంది. టు ఇంక్రీజ్ ద వోల్టేజ్, అవుట్పుట్ వోల్టేజ్. ఆప్షన్ సి ఈజ్ ద కరెక్ట్ ఆన్సర్. ఓకే, నెక్స్ట్ క్వశ్చన్. 10 dry cells are connected in series, it will produce 15 volts. Okay, 10 dry cells are connected in series, the terminal voltage is 15 volts. Okay, if they are connected in parallel, what will be produced? Okay, what will be the output voltage? Okay, 10 dry cells, each is having, let us say E, are connected in series. Okay, the EMF, terminal EMF is Vt, terminal voltage is Vt, each cell is having E. Okay, now Vt is equal to number of cells into E. Okay, E is EMF of each cell. Okay, the terminal voltage is given, terminal voltage is 15 volts. Okay, number of dry cells is 10. Okay, we have to find E is equal to 1.5 volts. Okay, E is equal to 1.5 volts. Now these cells are connected in parallel. Okay, E. Okay, like this, same 10 cells are connected in parallel. Okay, now we have to find here terminal voltage Vt, each is having E. Okay, now EMF, the voltage in parallel is remains constant. Okay, the terminal voltage is also E. Okay, terminal voltage also E. Okay, the value of E is 1.5 volts. Okay, from the options, option A is the correct answer. Okay, next question. Which of the following given material is not a insulator? Okay, మనకి ఇచ్చిన ఆప్షన్లలో ఇన్సులేటర్ కానీ మెటీరియల్ ఏంటి? ఓకే, బెకలెట్ ఈస్ వన్ ఆఫ్ ది ఇన్సులేటర్. అలాగే రబ్బర్ ఈజ్ ఆల్సో వన్ ఆఫ్ ది ఇన్సులేటింగ్ మెటీరియల్. ఓకే, అలాగే మైకా ఈజ్ ఆల్సో వన్ ఆఫ్ ది ఇన్సులేటింగ్ మెటీరియల్. ఓకే, బట్ కార్బన్ ఈస్ నాట్ ఇన్సులేటింగ్ మెటీరియల్. ఆప్షన్ సి ఈజ్ ద కరెక్ట్ ఆన్సర్. ఓకే, నెక్స్ట్ క్వశ్చన్. ఫుల్ ఫామ్ ఆఫ్ ACSR. ఓకే, ACSR యొక్క ఫుల్ ఫామ్ ఏంటి? ఓకే, ఫుల్ ఫామ్ ఆఫ్ ACSR ఇస్ అల్యూమినియం కండక్టర్ స్టీల్ రెయిన్ఫోర్స్డ్. ఓకే, ACSR ఫుల్ ఫామ్ Okay, aluminum conductor, steel reinforced. Okay, aluminum conductor steel reinforced. Okay, aluminum conductor steel reinforced అనేది మనకి ఇలా ఉంటుంది. Okay, here in middle steel will be there. Surrounding conductors are aluminum conductors. Okay, these are aluminum conductors. Okay, this is ACSR conductor. Okay, from the options, option C is the correct answer. Okay, aluminum conductor steel reinforced. Okay, next question. Primary distribution is carried by, okay, primary distribution, 3 wire, 3 phase 3 wire, or 3 phase 2 wire, or 2 phase 4 wire, or single phase 4 wire. Okay, primary distribution మనకు primary distribution లో 3 phase 3 wire ఉంటుంది. ఓకే, 3 phase 3 wire. ఓకే, అలాగే secondary distribution లో 3 phase 4 wire ఉంటుంది. 3 phase 4 wire. Okay, but in the question they are asking primary distribution la 3 phase 3 wire system. Option A is the correct answer. Okay, next question. The thermistor is a device whose resistance is, okay, thermistor is a semiconductor. Okay, thermistor is semiconductor is a negative temperature coefficient. Thermistor is having negative temperature coefficient. If temperature increases, resistance will decreases. Okay, that is negative temperature coefficient. Okay, negative temperature coefficient. Okay, thermistor is a device, resistance reduces with temperature increases. Yes, option A is the correct answer. Okay, if temperature increases, resistance will be decreases. Okay, next question. An energy meter is dash instrument. Okay, energy meter అనేది ఏ ఇన్స్ట్రుమెంట్? రికార్డింగ్, ఇండికేటింగ్ ఆర్ ఇంటిగ్రేటింగ్. ఓకే, మనకి 3 types ఆఫ్ ఇన్స్ట్రుమెంట్స్ అని ఉంటాయి. ఓకే, ఒకటి ఇండికేటింగ్, సెకండ్ వన్ ఇస్ రికార్డింగ్, థర్డ్ వన్ ఇస్ ఇంటిగ్రేటింగ్. ఓకే, ఫస్ట్ వన్ ఇండికేటింగ్ ఇన్స్ట్రుమెంట్స్. ఓకే, సెకండ్ వన్ రికార్డింగ్, థర్డ్ వన్ ఇంటిగ్రేటింగ్ ఇన్స్ట్రుమెంట్స్. ఓకే, ఇండికేటింగ్ ఇన్స్ట్రుమెంట్స్ వచ్చేసి మనకి ammeter, voltmeter, wattmeter. Okay, like this. అలాగే ohm meter. Okay, etc. అలాగే రికార్డింగ్ ఇన్స్ట్రుమెంట్ వచ్చేసి XY ప్లాటర్. ఓకే, మన సబ్స్టేషన్లో ఉంటాయి. ఓకే, we will use it in substation. Okay, next ఇంటిగ్రేటింగ్ ఇన్స్ట్రుమెంట్స్ వచ్చేసి ఎనర్జీ మీటర్. ఓకే, ఎనర్జీ మీటర్. ఓకే, ఇంటిగ్రేటింగ్ ఇన్స్ట్రుమెంట్స్ వచ్చేసి ఎనర్జీ మీటర్. ఓకే, ఎనర్జీ మీటర్ ఎక్కడ యూజ్ చేస్తాం? మన ఇంట్లో డొమెస్టిక్ పర్పస్ మనం హౌ మచ్ ఎనర్జీ వీ హ్యావ్ కన్స్యూమ్డ్ అనేది క్యాల్కులేట్ చేయడానికి వాడతాం. ఓకే, ఎనర్జీ మీటర్ ఈజ్ ఏ ఇంటిగ్రేటింగ్ ఇన్స్ట్రుమెంట్. ఆప్షన్ సి ఈజ్ ద కరెక్ట్ ఆన్సర్. ఓకే, నెక్స్ట్ క్వశ్చన్. వాట్ ఈస్ ద వాల్యూ displayed in the voltmeter in the given figure? Okay, here 5 volts is there. Okay, I will read out the circuit. Here 5 volts and 4 kilo ohm and 1 kilo ohm are connected in series. Okay, and the voltmeter is connected across 1 kilo ohm. Okay, now we have to find current here. Okay, current I is equal to V by R equivalent. V is 5. Okay, alage R equivalent here 4 ohm and 1 ohm are connected in series. Okay, so equivalent resistance is 4 plus 1, 5 kilo ohm. Okay, 5 kilo ohm. Okay, 5 kilo ohm. Okay, now we will get current is equal to 1 milliampere. Okay, now 1 milliampere is current is flowing through this 4 kilo ohm and 1 kilo ohm resistance. Okay, here we have to find voltage across 1 kilo ohm. Okay, voltage across 1 kilo ohm is equal to resistance. Current through 1 kilo ohm is 1 milliampere into 1 kilo ohm. 1 kilo ohm is equal to 1 volt. Okay, 1 volt. From the options, option D is the correct answer. This voltmeter reads 1 volt. Okay, 1 volt. Okay, next question. Ammeter provides passage for, okay, ammeter, minimum current, minimum voltage, maximum current or maximum voltage, okay. Ammeter is connected in series with load, okay. Let us say this is load, okay. Here we will connect ammeter. Ammeter is connected in series with load, okay. Ammeter is connected in series with load, okay. Ammeter carries load current, IL, okay. Same IL current will be flowing through ammeter, okay. Ammeter allows load current, okay. Load current is maximum current, maximum load current, okay. Okay, ammeter allows maximum current. From the options, option D is the correct answer. Ammeter allows maximum current, okay.